Right, this is like doing the first part of the lesson, but we're doing it second. This is actually in many ways a lot easier than composition of functions, but it might be brand new to you. Might never have done this before. It's very, very simple. What this is saying function f plus function g. Well, here are your functions, write them down. If you had function f of x, which is x plus 3, and you added on function g of x squared plus 2x minus 3, all you're trying to do is, let me just delete what I just wrote there. You just got that. That's all you have to do, and simplify it. So combine them together. You've got x squared plus an x here and another x here. So you've got x squared plus 3x. Then you've got plus 3, take away 3, they're gone. That's all there is to this. There's nothing more to it than that. Okay, so what would f plus g of 2 be? Well, you can do this two ways. You can either add up f and g algebraically and get this, and then put 2 in there. Or what you could just do is you could put input 2 into g, input 2 into f, and add them up. See which way you find easier. Have I not got the answer saved? Oh my goodness, I might actually have to write this for you. Oh, that's awful. Maybe it's underneath here. Come on, have my answers. No, there's not one I prepared earlier. So let's see, let's get writing then. Okay, so what we've got here, we've got, oh, come on, pen. So first of all, we have to f of 2. Let's do that in green. So we've got f of 2 is 2 plus 3. Oh my goodness, that's difficult. That's 5. And then we've got g of 2, and g was written in blue. I'm just color coding it. G of 2 equals 2 squared plus 2 times 2 minus 3. So this is 4 plus 4, which is 8. Take away 3, that's 5. So my answer for f plus g of 2 is this 5 plus this 5. So my answer on that question is 10. That wasn't very difficult, was it? Would you like to try the next two on your own? So pause your video, give it a go, and let's come back to the answers. Okay, starting up. So this would be, ooh, look, let's move that mess out of the way that I wrote before in my nasty, horrible, disgusting writing. Okay, all you've got is f, which is x plus 3, minus g, which is x squared plus 2x minus 3. You need these parentheses because you're subtracting all of this. So remember to distribute all the negatives to this. So you'd have negative x squared. This gives you negative 2x plus that x just gives you minus 1x. And you've got negative 3, which gives you plus 6. This, oh, no. Negative, it's not multiplied by 2, just negative 3 is plus 3. Plus another 3 gives you plus 6. And this one, I did have the answer hiding there. Your function of 4 is 4 plus 3. G of 4 is 4 squared plus 2, 4 minus 3, which equals 21. And the question says do f minus g of 4. So you've got 7 minus 21. Your answer should be 21. Oh, there we go. 7 minus 21 gives you negative 14 as your answer. Sorry, I'm just giggling. These ones I've prepared before. I've not done this very well. Okay, moving on. Oh, wasn't that nice? Let's see. What have I not talked about here that I should have done? Find the function f plus g of x and f minus g of x and state the new domain. Okay? Well, you have to consider the domain of f of x was all real numbers. There was no square roots. There was no dividing. So there was no things to exclude from the domain. The domain was all real numbers. Same with g of x. Now, when you're doing the domain of two functions put together, you've got to check if there's any restrictions on either of those domains. You've got to put those together and anything that's in the domain of them together must be in both of those. So it's where they overlap. It's not them added together, it's where they overlap. And you need to see if you're going to introduce a new restriction. So that's never going to you're not going to introduce a new restriction by adding or subtracting or multiplying. You will bring in a new restriction if you ever have one function divided by another function, because the functions at the bottom must not be able to equal 0, or you'll be dividing by 0. Let's see if we can find an example of that. Okay. So the product of two functions just means multiplying them. So if I have this function here, again, its domain is all real numbers. This one, its domain is all real numbers. There you go. If I want to do f, look at how differently this is written. This means multiplication, not composition. If it was composition, this would be an open circle there, not just a dot meaning multiplication. This means f multiplied by g of x. So you just write your f of x, your g of x. Now you have to multiply that out. So distribute x to everything, distribute plus 3 to everything, and add those together. So my first line is coming from distributing this x to all of those in g of x, yeah? So x times x squared is x cubed, x times 2x is 2x squared, x times minus 3 is minus 3x. Then everything in this second factor needs to be multiplied by plus 3, which gives you this. Now, when you're writing it out, why not line them up by their powers of x? Then you know you can combine x's with x's, x squared with x squareds, and it makes it much easier to add up. So that would be your answer for f multiplied by g of x. Let's try f multiplied by g of 2. Now, when it's numerical, you can do it a totally different way. You don't have to do all this horrible algebra first. You can just say, right, I'm going to put 2 into g, and what comes out if you put 2 into g? Oh, that's a bit of work. 2 squared plus 2 times 2 minus 3. That gives you... haven't got that written out for me. It'd be 4 plus 4 is 8 minus 3. That would give me 5. And f of 2 would be 2 plus 3. Well, that one got the answer written out. Why have I not got the answer written out for that one? Okay, so this would be 5 times 5. 5 for f of 2. 5 for g of 2. Which I've written equals. I have to write it. It's annoying me. That one simplifies to equal 5. So you've got 5 times 5 with the answer 25. Okay, this one we're not being asked for the domain because we're just being asked for one particular x value. We're not being, we've been told what x is. X is 2. We're not being asked for. And what values of x is this all valid for? And that one, it's all real numbers. I'm sorry, my dog's squeaking his squeaky ball. Hello, Murphy. He's bored. He's bored. Let's have a look at division then. Division is going to bring in a new problem. Sorry about the dog. So we've got the same two functions. Let's look at f divided by g of x. Murphy, shh, shh. I don't know if you can hear him squeaking his ball. It's annoying me. So we know that the domain of f is all real numbers. I haven't got that written. Domain of g is all real numbers. If I did f divided by g, I would have x plus 3 divided by x squared plus 2x minus 3. Does that simplify? Yes. It simplifies. We can factor that denominator, and when we factor it, look what we can do. There's a factor there in the numerator that cancels a factor in the denominator, and I'm left with, that is my answer. Now, if I just looked at this final answer, what would my domain be? This is saying x cannot be 1, because if x was 1, I'd be dividing by 0. So this is telling me that I know x cannot equal, well, that's wrong. Oh, look at that. I had a problem from my presentation from years before. X can't equal plus 1, not minus 1. However, you have to look back at what was originally here. there was also another x value that x can't be. Even though we've eliminated it, it was originally in the denominator. X can also, even you can't see it at all in your final answer, but it's still a restriction on your domain. X cannot equal -3 or +1. So let's have a look at this one. On this one's numerical, we're not being asked for domain. We just have to put 2 into F, get an answer, put 2 into F, out pops 5, put 2 into G, out pops 5. So what's my answer of F of 2 divided by G of 2? 5 divided by 5 is simply 1. Let's try one more example. Let's have a look at this one. These are much more complicated. So if I have these two functions, first of all, what is their domain? They've got square roots, so their domain is not all real numbers. Let's have a look at this one. X, you can only take a square root of something positive that's 0 or bigger than 0. So we know that our x values have to be, let's solve that, x plus 1 has to be greater than or equal to 0, x has to be greater than or equal to -1, which would give me that on a number line. Okay, and on this one, I know that 2 minus x must be greater than or equal to 0, which tells me that x must be less than or equal to 2, or 2 is greater than or equal to x, whichever way you want to write that. So we get that. Now, if we put them together, just those two together, where they would overlap would be from -1 to that value there is 2. Okay, if we just put them together, my domain would be from -1 included to 2 included. But look what happens when I put this one down in the denominator. When I was looking at g of x, I said that x was allowed to be 2 or smaller, because if x was 2, it would be the square root of 0, and when I'm just looking at that, I can take the square root of 0. There's nothing wrong with an answer of 0. The only problem we have with it is if we put this in the denominator, now I have to exclude this when it does equal 0, because I'm not allowed to equal 0. So looking at that denominator, this whole denominator cannot equal 0. So I'm losing that equal sign there, and I'm getting this. Because this is in a denominator, now I have to exclude that too. So my domain for these functions when I put it together is where do all three of those lines, any point I want to include in my final domain has to be on both the blue bit, the green bit, and the red bit. So my final domain does go from -1, it's included on all three of those lines. It goes up to 2, but I have to exclude the 2, not include it. Okay, for a sum, difference, or product of the functions f and g, the domain would simply be from -1 to 2, where both of these domains overlap. But if I'm dividing, then whichever function is in the denominator is going to give me an additional exclusion in that it cannot equal 0. The whole denominator cannot equal 0. So you have to consider that a little bit. But I don't know how much we're actually going to ask you about this on the test. It can get a lot more complicated when we look at domains of composed functions. I think we just kind of show this to you to make you think about it. Have a look at it on your homework, but don't sweat it too much. Pretty sure we've not normally asked about that in a test. Okay. Oh, let's carry on. There's one little bit more. Let's have a look at these. These are nice. These are much nicer than when you're doing algebra. Remember when you're putting in a number, this is f plus h of 6. Look at your graph, f of 6, put 6, x is 6 into f. F is the blue one. Out comes -10. Put 6 into h. H is the green one, put 6 in there, out comes 4. And our question is saying, get f of 6 and add on h of 6. I add those together, you get the answer -6. Try the other two, pause your video and come back and see. So, I don't know if you've even got the answer to 16 written. Let's try it. I would have, am I going to have to write this with my mouse? Let's see if I can do this. Scratchy writing. So what we're being asked for here is g of 6 So x is 6 going into g, which is the red one. Oh, what comes out? On the red one, that's on the x-axis, so that is y is 0. That equals 0. And h of 6, put 6 into h, which is the green one. Out comes 4. And the question here is asking you for g of 6 minus h of 6, 0, subtract 4 equals -4. Okay, let's have a look at number 17. That's supposed to be multiplication, I think. It's nastily written, isn't it? H multiplied by g of 4. So you'd find your h of 4 and you'd get 1.5. Where did that come from? Let's have a look. Let's put 4 into h. So x is 4 into h, which is the green one. Ooh, it's, that's about 1 there. Yeah, it's definitely above 1. It's either 1 or 1.5. See, we've put in the wobblies there, saying, well, I'm not really sure. It's a bit dodgy, isn't it? About 1.5. Looks a little bit bigger than 1. And your g of 4, put 4 into g. 4 goes into the red one. Out pops. That looks like -2 to me. Okay, and you're being asked to multiply them together. 1.5 times -2 would give you -3. And I think that's probably it. Yes, you're ready to do your homework. That's the end of the 2 days worth of lessons there. So you should be able to do all of the homework from this point. Good grief. Doing mice doing weird things. Goodbye.